Okay, today we're going to present our last webinar regards the Safety Cyber Lifecycle Overview. This is part 4 of a 4-part series. Before we get started, just let you know that Exida is got a global presence. We're not huge, maybe 100 employees, but a lot of knowledge and experience, and as I said, we have a global footprint. With regard to our main products and service categories, they're listed here. Those items in green are those that pertain to cybersecurity. A little bit about myself. Been kicking around for over 40 years. Started out as a process control engineer for about a decade, and since then I've been in process safety. The last 7 or 8 years, cybersecurity has become very important with regard to process safety, so I've gotten involved in that area. And pertinent to this webinar, I currently am the chairperson for Working Group 9 of the ISA S84 Committee on Safety Instrumented Systems, and that working group is dealing with cybersecurity relative to the SIS and its associated industrial automated control systems. Throughout the series, the 4-part series on the life cycle, our objectives here are to give you an overall awareness of the cybersecurity life cycle. The first 3 parts, analysis phase, design and implement phase, and operate and maintain phase, those were focused if you were to take a new capital project, a greenfield site, and you started from scratch and you did everything and worked your way through it. Part 4 now is considering the brownfield or the existing site where maybe cybersecurity by the control personnel, control technicians, engineers, maybe they haven't paid that much attention to cybersecurity, or maybe they have but haven't really maintained themselves up to industry guidelines. So we will talk about how to enter the life cycle from an existing field site. Now, before I go on, as we go through this webinar, if you think of any questions that you would like answered, please write those down. We will have plenty of time before the hour is up to respond to your questions and answer any questions that you may have. So one of the objectives not only is to get a feel for and an understanding of the overall life cycle, but also how it integrates in with the life cycles that you may have previously been familiar with on the process safety side or the functional safety side. They all have an assessment phase or an analysis phase. They all have a design and implement phase and an operate and maintain phase. The key thing is, if you're looking at the life cycle, say the functional safety life cycle as it's documented in either S84 or IEC 61511 for safety instrumented systems, you want to take a look at how would those aspects of cybersecurity integrate with those kind of programs that you already have in place. Obviously, there's a lot of things unique to cybersecurity, but the general work process flow, a lot of that you can leverage a number of programs that you already have in place so that you can have a seamless work process. Here's the flow chart that we put together for entering the life cycle from an existing site. First thing you need to do is make the decision as to whether you are or are not going to implement cybersecurity for the industrial automated control system. Assuming that you say yes, the first step is to perform a vulnerability assessment. that generates a vulnerability assessment reports. That report can be broken down into various topic areas as listed below. And after you've addressed those topic areas, then that becomes good input to the assessment phase of the life cycle, and then you can progress on down through and actually implement across the board. All of those topic areas we will cover in more detail as we go through the slides. Starting with the vulnerability assessment itself, the whole intent of that control system vulnerability assessment is to compare what you have in place, both in terms of your network design, what countermeasures you have in place, your administrative controls, physical controls, and compare all of that to the appropriate industry standard for your industry. So if you're in the power industry, you might be looking at NERC-CIP. If you're in the process industry, you're more than likely looking at the ISAS 99 coupled with the ISA/IAC 62443 series of standards. Coming out of that vulnerability assessment, you'll have recommendations. Once you see where you have deficiencies relative to benchmarking against the industry recognized and generally accepted good practice, you can come up with recommendations to address those potential vulnerabilities. This provides the kind of benefits that it's a methodical way of doing things. It provides greater comfort with management because they have a better understanding of just what the current situation is. Once you know the gaps, you can prioritize those gaps and move forward. Details of the vulnerability assessment: you're going to review existing site security practices and policies. Part of that may be looking at what the corporate practices and policies are that the site needs to adhere to. The control system network architecture will be looked at and reviewed versus good practice. Configuration data sample will be collected for the various network equipment and control devices, and once again taken a look at against best practice. Employees will be interviewed, key employees interviewed that is, and they would typically be folks in operations, process control, information technology, those folks who are involved in operating and or maintaining your cybersecurity, and recognize that even though you might not think operations personnel operate and maintain the cybersecurity, they certainly are impacted. Their operability is certainly impacted by it, so they have to have a certain amount of understanding of what is important so appropriate decisions can be made. Operations, IT, process control, they all have activities that are specific to their functional area, but they also have responsibilities that require an overlap with those other functional areas so that optimal decisions, optimal solutions can be obtained. As part of all of this, report findings are documented, which compare industry best practice. As I said, it produces a gap analysis, which then leads to recommended potential solutions so that you can bring the facility up to speed with respect to your corporate risk criteria ultimately. But the baseline would be to see where you are from the basic foundation of recognized and generally accepted good industry practice and the acronym for that is RAGAGAP. Key points in the vulnerability assessment: you're going to want to monitor with the eye towards ultimately improving the control system management system, the CSMS. You're going to be looking at conformance. Is it being followed? Is it documented? Are you performing appropriate audits? If you are, fine. If not, then those are opportunities for improvement. In all cases, the conformance should be periodically reviewed so that the CSMS can be maintained to an appropriate degree of integrity. It's important to ask the question, are the security objectives being met, or be able to answer that question. And if the answer is no, then you're going to need to change that CSMS as appropriate. Other additional discovery items that occur during vulnerability assessment that get focused on: looking at network traffic, monitoring how it's evaluated, how the devices are configured relative to best practice. Also take a look at how wireless is addressed, as that is also a avenue where you can be breached. Output, we've talked about a couple times already. You've got the gap report. You end up with an itemized list of the current state versus the industry best practice and standards that is applicable to your site, and associated recommendations based upon those gaps on how best to upgrade the plant to achieve best practice and industry standards. It's also important to note right now that once you have this snapshot, this vulnerability assessment, that becomes a very, very important input to both the high level and the detailed level cybersecurity risk assessments. We had talked about those two in the part one when we were looking at the analysis phase of the life cycle. And the next two webinars that I present, I believe in December and January, one will be on that high level cybersecurity risk assessment, and the other will be on the detailed level cyber risk assessment methodology. So you've got your list of recommendations. One of the important topic areas was policies and procedures. Difficult to do anything if you don't have senior management support, so that's required. Depending upon what your organization is, you may need to establish it, or you may need to tweak it if it's not quite where you determine it needs to be. If it's not doing for you what you're hoping to achieve. Organizational responsibilities need to be defined. If those definitions are deficient, then that becomes something to target, as well as defining the core team of stakeholders and updating, if creating or updating as applicable. You want to provide guidance that communicates expectation to employees and suppliers, so that's an important aspect of policies and procedures. The policies for sure should be technology independent. And also, policies should outline what you want to achieve, not how you do it. When you get into the how or specific technology, that's where specific standards and procedures can come into play. Industrial control system security policy topics. One of the things you'll need to do is determine which regulations you're going to compare yourselves to or use as your backbone. There's a lot of cybersecurity standards out there. Some are more relevant to certain industries. The one that exida is focused on is the S99 set of standards that is in conjunction with the IEC 62443 set of documents, as well as technical report 84.00.09. It's an ISA technical report that is dedicated to cybersecurity with regard to safety instrumented systems and basically the functional safety and cybersecurity lifecycle. As part of your topics that you want to address, what risk and vulnerability assessment requirements and methods are you going to use? There's a couple methods referenced in the TR 8409 document that I referenced. What's there and what I present in the next two webinars are not necessarily the only techniques out there, but ultimately you have to decide which ones work for your company. You also have to define your training requirements. What kind of personnel security requirements do you have in place? How do you screen your personnel before you're hired to make sure you don't have people who are going to be malcontents? If you release someone, what are the kind of procedures for having that person exit the facility and not have any opportunities to do damage to your system, for instance? You'll need to look at both physical and logical access control, remote access, how you manage your industrial control system information. Network segmentation becomes an important topic. We'll talk a little bit more about that later. Also wireless networking, use of portable media, what level of countermeasure integrity do you have with the various countermeasures that you have in place? Various countermeasures might involve patching, antivirus software, ongoing metrics. They can be live metrics or online metrics or periodic manual metrics, intrusion detection, inspection, and testing. You want to make sure that cybersecurity is integrated with your overall management of change program. Don't want to just do it lip service. You want to make sure that those changes to your network, that you truly identify when changes need to be managed. So you need to have the right people involved looking at those things. Also, we want to address business continuity with regard to backup and restoration of services, and that's pretty tightly tied in with incident response, and there can be a variety of incident responses based upon what the potential risk of a particular device or a particular zone being compromised. So those incident responses may be different. That should all be looked at ahead of time and documented. So those are areas that topics that should be addressed in your security policies. With regard to training, if you have good training, it's going to help reduce accidental incidents. It will also help reduce the likelihood of successful attacks. Awareness training more than likely should be targeted to all personnel and contractors. Companies have a lot of contractors coming on site. They're doing a lot of things, particularly in maintenance. And just about all equipment, it seems, these days have some kind of programmable devices, some sort of communications going on. And if that's not properly managed and the personnel are not properly trained, then you can increase the likelihood of successful attack or accidental incidences. Screening of personnel, both upon initial hire and also periodic rescreening, paying attention to social media, that kind of thing can help reduce deliberate actions. You want to target additional training by their functional role. So senior management needs to understand the high-level stuff, the relative risk of what's going on, so that they can help make decisions regarding allocation of resources. Same with management. When you get into engineering and IT and operations, as I talked about before, they're all going to need some level of overlap to understand what each group is doing, so that things don't fall through the cracks. But they'll also need to have the more specific activities that are specific to their responsibility, their functional role. Access control, need to consider your administrative controls, need to take a look at how you control physical access as well as logical access. Logical access are the 3 A's: administration, authentication, authorization. As part of looking at access control, you're asking questions like who has access, what resources do they have access to, and what level of privileges do they have once they get access to those resources, and how is all of the access control enforced. Answering those questions gives you a baseline of what you have, but then you got to go to the next step and ask the question, do the right people have the right access? Are we giving access to more people than is necessary for that function, for that role? You really want to look at least privilege, where you're minimizing the number of people who have access to things. If you just open it wide up, then it's much more difficult to control and enforce. Additional aspect is hardening system components. When you harden system components, you start with physical hardening. If you recall the Stuxnet virus, that was a virus that was loaded onto Siemens control systems, and it was designed to look for control systems that were controlling uranium enrichment centrifuges. It was designed to overspeed them while making it look like they were under control and bypassing all of the soft-wired safeguards. The Iranians didn't know that their centrifuges had a problem until the centrifuges started to experience mechanical damage. Physical hardening would have, if those ports would have been removed or disabled, certainly if they would have been removed, then there would have been no means to introduce that virus onto the control system. If the ports were disabled, it certainly would have made it more difficult. There would have had to be more work done in order to be able to introduce the virus. Other means of hardening your systems is to have an active patch management program. Companies, industry is discovering new vulnerabilities, either because they discover it themselves or some company was hacked and a vulnerability caused them some discomfort or undesirable consequence, at which point the vulnerability is addressed, patch created, and that one can be eliminated or mitigated. Patch management is one of those batch exercises, so that's why you need the management program. It's a little bit of a double-edged sword. If you just indiscriminately implement patches, you may introduce other problems. So as part of your patch management program, you want to do appropriate testing before you actually do a patch on a critical system. Antivirus software, antivirus protection management, basically the same thing, just a different means of protection and different threat vector. Whitelisting is another way to harden components, where you only allow those programs that you've specifically approved, and any program that was not approved, as soon as it's detected, it's isolated and quarantined. You know, it might be benign, but unless it's approved, the assumption is that it's malware. It shouldn't be there, so isolate and quarantine. Also, looking at products that have been certified to some level of security robustness. That's always a pretty good idea. Even if it's not certified, you should be asking the questions about just what kind of attributes. I'll just give you an example. Not all firewalls are created equal. Some are general purpose, that the security could be very variable depending upon what the end user physically configures when they get the firewall. Other firewalls might have eliminated or reduced that level of configuration by putting a lot of stuff in firmware, so it's much more secure. Other firewalls may have that firmware with deep packet inspection. So, as I said, not all firewalls are created equal. How good they are or how effective they are is really a function of what specific attributes and capabilities the firewall has, as compared to the potential threat vectors that can come from the internet external to the facility, down through the firewall into your industrial automated control system. Here's an example of an incident that occurred. There was an operator on an oil platform. They knew they had an SQL vulnerability and were actively pushing patches out. However, they didn't have enough qualified IT personnel, so the timing of actually getting the patches not just loaded, which they were, but in order to have them enabled required a reboot, but the lack of qualified IT personnel prevented that reboot for some period of time. Unfortunately, prior to actually getting the patch implemented, even though it was installed, it was not implemented yet, the slammer outbreak occurred, and there was a resulting loss of view and loss of data on that platform, or some platforms, as a result. Segmenting the network is a means to implement a defense in depth strategy. The idea is to partition the system into security zones. You want to group those assets that share common security requirements. So, for instance, if I've got devices that only have to achieve a security level 1, it doesn't make a lot of sense to load those or combine those with devices that need to meet a much more stringent security level requirement, say security level 4 or security level 3. Within the zone, there can be subzones that provide, additional layered security. When you're looking at the network segmentation, you really want to define the strategy for each zone based upon the objectives that you're trying to achieve. I note here that a very, very useful input when you're looking at this segmentation is to have already performed a high-level cybersecurity risk assessment. Very useful input, because it's supposed to very quickly, in a day or two, allow you to look at device types as a category as a function of different process areas or utility areas, and look at what level of consequence could occur if that device was compromised. When the consequence can be severe, then that's going to lead you to think in terms of a higher security level. When the consequence is not as severe, then that would lead you to think in terms of a lower security level. And breaking out those zones into different security levels certainly can save you money if you just assume that the world is always going to cave in. Then everything becomes security level 4, and you end up with a very expensive system, which is not really where you want to be. When you've got conduits between zones that facilitate zone-to-zone communication, you want to make sure that the security level that you're achieving for those conduits are the greater, the more rigorous security level between the two zones. Now, once you've gone through the vulnerability assessment, once you've started to bring the facility up to speed with regard to, or identified what you're planning to do to bring it up to speed with recognized and generally good industry practice, you can then begin to contemplate going through the full life cycle, starting out with the assessment phase. So I've already mentioned a high-level cybersecurity risk assessment. That would actually be part of the risk assessment too, but it is best done in conjunction with at least your initial putting together of your segments, your segmentation into zones. Once you have what you plan to have for your architecture, your final architecture, or your final proposed architecture and segmentation, you can do a detailed level risk assessment. That might cause you to identify things that you hadn't considered, might impact some of your prior decisions as to what you're going to include in certain zones or what kind of countermeasures. Both the high level and the detailed level, those will be the next webinars that I present, as I said earlier. Coming out of the risk assessments, there will be recommendations, and those will need to be addressed. Depending upon what those recommendations are, I did not put a slide in for the design and implement because the plant is already in place, but it is possible that you may have to have some capital projects in order to upgrade your installation. Maybe yes, maybe no. If yes, then you would actually go through the design and implement phase for that work. In either case, you will always be back into the operate and maintain phase, where you want to make sure that you've incorporated cybersecurity into your management of change program. You want to make sure that your backup and recovery management system is adequate for the risk that may be present. You want to make sure that your incident response planning is not just planned, but actually documented and in place with personnel trained. You want to have in place a program for inspecting and testing your countermeasures. You want to have your metrics in place. Those metrics may be periodic manual measurements, or they might be online diagnostics, which could be considered part of your inspection and testing, which would be online and continuous. And finally, periodically, you're going to have to revalidate your assumptions and current integrity. This is equivalent to revalidating say your hazard review that is done as a result of process safety management requirements. Same thing needs to be done here. In PSM, or process safety management, that requirement is generally to not exceed 5 years. So I would suggest that you don't exceed 5 years for cybersecurity, but also caution you that with the evolving state of cybersecurity, that may be too long. You may want to consider doing that reassessment more frequently, or keep it at 5 years, and as part of your countermeasure inspection and testing and your online diagnostics, essentially the performance measurements that you have in place, if you find that your assumptions that were made are not allowing you to satisfy your corporate risk criteria, you could then include in your policies and procedures to use that as a trigger to revalidate and redo the cyber risk assessment based upon what you're learning, and thus short circuit the time frame, and that can make things occur more frequently. And you can think of that as condition-based revalidation. So, in summary, assuming that a decision was made to address cybersecurity within the industrial control system, first step is to perform a vulnerability assessment, after which you've got a bunch of recommendations that addresses either upgrades to or development of policies and procedures, either development of or upgrades to training that should pertain to both personnel and contractors. Also include controlling access to the network, harden your system components, segment your network so that you can achieve the defense in depth that's necessary, achieve the security levels necessary for you to satisfy your corporate risk criteria. A lot of that comes out of the when you perform the assessment phase activities, mostly the detailed level cybersecurity risk assessment. That's specifically where you are looking at the likelihood and consequence of various threat vectors, threats and threat vectors, and whether or not you are satisfying your risk criteria or not. If you're not satisfying your risk criteria, you're going to want to make recommendations. Once you're in the life cycle, you just continue to exercise the life cycle activities throughout the life of the facility. So with that, I'd like to ask if anybody has any questions. At this point, I would be happy to answer those. Seems like I always get more questions in the morning session, but I want to give you guys a chance. Just write in any questions that you may have, and happy to answer those. Just give you a couple more minutes to, in the event that someone has a question. I will say that if you think of a question later today, tomorrow, next week, next month, feel free to contact Exida with that question. We'll get back to you as best we can. And there's contact information, www.exida.com. You can contact us. Okay, not seeing any questions at this point in time. Well, that one popped in there. So, may I know what is the frequency of patch and antivirus management? I don't believe anyone will ever tell you there's a specific frequency for either one of those things. If you have antivirus software and nobody is identifying new vulnerabilities, the same thing with patches, then you're not going to update for a long period of time. So it's really dependent upon vulnerabilities being identified, and then manufacturers notifying you that there's an update to be had. What becomes important from an end user perspective is that once a manufacturer or a software provider notifies you of a patch or an antivirus software update, how quickly you update is what's important. What's important is your work process for making those updates. Where you have critical equipment, you want to get it out there more quickly, but at the same time, you want to make sure that when you get it out there for your critical equipment, that you didn't create more problems than you would have had otherwise. So oftentimes, say with a patch or antivirus software, you'll roll it out very quickly on something that is not all that critical to you, just to make sure that there's no unforeseen surprises. Once you're comfortable that it's doing what it's supposed to be doing and not causing you undue hardship that you didn't anticipate, then you roll it out to the more critical stuff. How quickly you exercise that work process, as I said, really becomes a function of what you've been experiencing within your site and how critical the devices are. Okay, next question is remote access to access engineering workstation to be restricted for doing bypass operations. Anytime I'm looking at remote access, and particularly when I'm looking at remote access to an engineering workstation, I want a fairly rigorous procedure, and I want, even if I have help off-site, I want somebody on-site to be giving access and seeing what's going on when it's being done. Unrestricted remote access is a bad idea across the board. Anyway, that's one person's view and opinion. Remote access, not properly managed, can get you into a lot of trouble.